Welcome to Space Tech Insider.
Have you ever wondered how a towering rocket, blasting off with incredible speed, manages to hit a tiny target in orbit millions of miles away, or even lands precisely back on Earth? It seems like an impossible feat of accuracy, doesn't it? The direct answer is that rockets correct their trajectory using a sophisticated system called guidance, navigation, and control. Often referred to as GNC, this integrated system constantly monitors the rocket's path and makes precise adjustments throughout its flight to ensure it reaches its intended destination. The reason this system is so effective lies in its core components and how they work together. First, the navigation part involves an array of sensors, such as accelerometers and gyroscopes, which continuously measure the rocket's position, velocity, and orientation in space. These sensors detect even the slightest deviation from the planned flight path. Next, the guidance element is the rocket's onboard flight computer. It takes the real-time data from the navigation sensors and compares it to the pre-programmed ideal trajectory. If there is a difference, the computer instantly calculates the necessary correction. Finally, the control aspect comes into play. The flight computer sends commands to various control effectors on the rocket. These can include gimbling engine nozzles, which swivel slightly to change the direction of thrust, or small thrusters known as reaction control system jets, which fire to nudge the rocket in the correct direction or control its rotation. For rockets flying in the atmosphere, aerodynamic fins might also be used to steer. All these adjustments work together to bring the rocket back onto its optimal course. One fascinating insight into this process is the concept of a closed-loop control system. This means the system doesn't just make one correction and stop. Instead, it continuously feeds current flight data back into the guidance computer, allowing for constant recalculations and adjustments. This iterative process, often enhanced by advanced estimation techniques like a Kalman filter, refines the rocket's position and velocity estimates, leading to incredibly accurate path corrections. Ultimately, this intricate dance between sensing, computing, and actuating is what ensures the success of space missions. Whether it is deploying a satellite into geosynchronous orbit, sending a probe to Mars, or safely returning astronauts to Earth, the guidance, navigation, and control system is the silent guardian, constantly keeping the rocket on its true path and enabling humanity's incredible journey into the cosmos.
Join us at Space Tech Insider, where innovation meets the infinite. Discover the future today.